Alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. Now, in this particular video, I'll be focusing on this particular paper, which is June 2023 variant 11. Now, this is the examiner report. Let me get started with the examiner report first. First of all, there are some key messages, and then there are general comments, and then there are comments on specific question, for example, question 1, for example, question 2. And let me highlight each one of them. So because I'll be going through all of them so that you have a pretty good idea what is the requirement of the examiner, what are the ways of not losing the marks, because everyone thinks from their perspective they are doing it great, but the grades, they are not the same for everyone. So if you want your grade in a proper manner, an A or an A star, so you have to work things out according to the examiner report. So now there are 12 questions in this particular paper, and maybe I'll do few more questions from the next paper also, but this particular paper, I'll do it all. So let's say our threshold is like 75 minutes. So in 75 minutes, approximately, we should be able to understand this paper. The paper is already solved. Now, first of all, let me highlight few things. And those few things are this. Our previous reports, I'm reading the key messages. Previous reports have highlighted that the rubric, the standard on the front cover of the question paper states no marks will be given for unsupported answers from a calculator. That is written at the front. So let's read the front. And it's about this thing that you should use a calculator where appropriate. You must show all necessary working. No marks will be given for unsupported answer from a calculator. This is that exam report thing. So now turning back to this, make sure that you show all essential steps, every single step that I have shown in class. So whatever I have shown in class, just follow it exactly. No ifs, no buts, just follow it exactly. All good? Now it says further that although most candidates have taken this message on board, there is still a significant minority who have not. To justify solutions, clear working must always be shown. This is the basic thing. This is the starting point. No compromise on this. The next thing. Now it's talking about quadratic equations. For quadratic equations, it would be necessary to show factorization, use of quadratic formula, or completing the square as stated in the syllabus. Now, let me add one thing over here. When we are talking about completing the square, we need to show the process. Make sure the coefficient of x square is 1. First add, then subtract square of half the coefficient of x. Rewrite the first 3 terms as a perfect square. So that is the process. I do not agree with the idea of comparing coefficient. That's why I have not taught comparing coefficient in the context of completing square. Keep that in mind. And then it further says, use calculators. Using calculators to solve equations and writing down only the solution is not sufficient. This is not sufficient. Keep that in mind. And I should highlight not also. Actually, let me highlight it with red. So it's not sufficient. It is also insufficient to quote only the formula. Candidates need to show, excuse me, values substituted into it. That is the quadratic formula. It's all about quadratic equation. Factors must always produce the coefficients of the quadratic when expanded. That means when you do when you do middle term factorization, make sure the 2 brackets that you get, they multiply to give you the original one. Similarly, when we talk about integration, with definite integrals. A detailed method showing limits substituted must support the final answer. And I'll show all these things in this particular paper, which is June 2023, variant 11. Using a calculator for integration is not sufficient, although it can be helpful for checking. So just for checking and nothing more. And that also if you are underconfident. If you are just normal confident, you have done all your working, as such, you don't even need it. And then it further says it is always advisable to read the question carefully to see whether later parts are linked with earlier parts. That means read complete question. So read complete question once at the beginning and then go to the parts. And in some question, it was necessary to use values found earlier. And over here, let me add one thing which the examiner forgot. That is use unrounded values for later parts. So now this is the key message that I focused on. I'll go to the general comments a little bit later on. So now let me go back. Let me first look at the question and then I'll go to the solution. So now this is the paper. That is May, June 2023, variant 11. And let's look at the first question. It says solve the equation for theta between 0 and 180 degrees. What is the question about? The question is about trigonometry. In trigonometry, it's about equation. In equation, it is about degrees. And it's about tangent theta is sine over cos. And maybe some middle term factorization might be there. So first decide what needs to be done for 3 marks. Let's look at this. So I finished this question last year in 6 minutes. And tan is sine over cos, background knowledge, first quadrant, second quadrant, because over here, why it is first and second quadrant? Because it's from 0 till 180 degrees. And then we know in the first quadrant, all the ratios are positive. In the second quadrant, only sine is positive. In the first quadrant, required angle is basic angle. In the second quadrant, required angle is 180 minus basic angle. You break tangent up. You do LCM, cross multiply, always take common. That is the supreme thing, because if you don't take common, you lose half of your solution. 2 things are multiplying to give you 0. Either one of them is 0. Sine theta is 0. Use the sketch. You get answer 0, 180, 360, and so on. But neither is 0 nor is 180 inclusive. So there is no solution, but you have to show the working. Cosine theta is negative 1/4, the 4-step method, the quadrants, the basic angle with the positive ratio, ignore the negative sign. And we are interested in the second quadrant only. So therefore, only one particular answer. So I hope the first question is all clear. So I'll be writing down the questions over there so that you can double check that is this all good, all clear? So a little bit acknowledgement and appreciation definitely from your side so that things are just on the right track. That appreciation is that you trying out the questions thoroughly, you doing the reciprocal work in making sure that you get the best possible grade under my guidance. So now this thing is all done, all clear. Let's move on. The second question, let me read it from here. So I want to read the question from a blank thing so that you don't get overwhelmed by the solution. You just first have a good look at it. Now, question number 2, part A. It says, find the first 3 terms in the expansion in ascending powers of x. And let me just check one thing. Okay, all good, all clear. So now in ascending powers of x, that is 2 plus 3x raised to power of 4. Find the first three terms in the expansion in ascending powers of x. So there is this bracket separate, 2 marks for each. And then the last part, multiply these two selectively because we need the coefficient of x squared. First term is not 1, first term is 1. So this is a plus b raised to power of n. This is 1 plus b raised to power of n. And then it's selective multiplication. So let me go back over here. The solution, 717 to 723, 6 marks. So I think it's for 6 marks and it took 6 marks, 6 minutes. So marks should equal minutes if you want to score your A star or A. That should be in the non-exam mode. And in the exam mode, this could be a little bit more. So 4C0, B raised to power of 0, A raised to power of n. Just following this, that's how you write it. Very simple. I can do this at the back of my head. I write it down. Where calculator is needed, definitely I'll use it. For example, 6 into 4 is 24, 24 into 9, I'll use a calculator. I'll even use a calculator over here. And then find the first three terms in the expansion of this. First, second, third term. These are the first three terms. 1696, 216, 1, negative 1040, 1696, 216, 1, negative 1040. Make sure when you read the question and rewrite, so you don't make a mistake of plus sign, minus sign, and so on. We are interested in coefficient of x square. So this 16 should multiply with this coefficient of x square because this is constant. This constant should multiply with this. This x term should multiply with this. So right over here, coefficient of x square, again, show all essential working. Whatever I do, that is essential. Multiply the green with the green, the blue with the blue, the red with the red, add it up, you get negative 104. That's how 6 marks are obtained. So now question number 2 is also done. So question number 1 was trigonometry. And now question 2 is binomial. So question 1 is trigonometry, question 2 is binomial. So I think both questions are done very, very well. AS1, AS2. I think I sent it again over here. Let me just go. So now let's move to question number 3. Your favorite topic, that is transformation of functions. The diagram shows the graph with equation y is equals to fx, y is equals to gx. This is fx, this is gx. Describe fully a sequence of two transformation which transforms the graph of fx onto gx. What do you observe? You observe that it is shifted to the left. That means there is some translation. Maybe left, maybe down, maybe right, maybe up, that we will determine. And the size has increased. Now this is 2 units, this is 2 units. But the vertical 1, 2, 3, 4, 5, 6, 7, and 8. If I compare this point with this point, there is a difference of 8 units. But if I compare this with this is 1, 2, 3, and 4. That means the size doubled along y-axis. So that is how you will determine the basic idea. Once you have determined the basic idea, now what needs to be done? You should play with this point, with this point, with this point, with this point. I think 2 are more than enough. And then based upon that, for 4 marks, you will write a fully sequence of transformation. The name of transformation, and what is the direction, and if there is a translation vector, write it down. Let's look at the solution. Now over here, fx to gx, this is -1, -3. The purple one is -1, -3. It's becoming this purple one, that is -7, -6. -1, -3 is -7, -6. Let me pick this red one and this red one, that is 5,3. 5,3, it's becoming -1,6. What do you observe? The y coordinate is multiplied by 2. the x coordinate, there is a decrease of 6 units. -1 reduces by 6 units, becomes -6. 5 reduces by 6 units, becoming -1. So now you are getting the idea that first of all, let me decrease. I think this is an S. So let me decrease of 6 units, x coordinate. It's a translation parallel to x-axis. So let me also write this. So this is translation vector is more than enough. So this is translation vector, which is -60. Or you can even write a horizontal translation. And then the translation vector. So 1 mark for this, 1 mark for this. And then second, there is a multiplication of y coordinate by 2. So this is a stretch parallel to y-axis, or along is also good. The scale factor is 2. So 1 mark for this, 1 mark for this. That is how it's asked. Now this is extra that I have done. What if they asked for the equation, write gx in terms of fx? So f bracket x plus 6, that means it's a shift of 6 units to the left. Shift and translation means the same thing, inside out. And then 2 on the outside. What is happening? That is a stretch along y-axis, scale factor 2, only if they ask for it. Now, few people, they ask this question, what if we first what you call stretched it and then translated it? Doesn't make a difference. I'll just show you over here. So over here, for this particular question, let me go to the mark scheme and stretch factor 2, y direction, translation -60. Transformation may be in either order. So that's not an issue. Transformation may be in either order. So that is all got all clear. So question number 3, transformation. I hope this is all got all clear. So AS1, AS2. And I think now I'll just write down if there is any difficult concept, because this kind of gets a little bit cumbersome for you and for me to write the message and then acknowledge it. So just ignore it. So now there it is. Question number 4. What is this about? It's about circular measure. So what's the first thing that needs to be done? Make sure that your calculator should be in the radian mode. Okay. So now your calculator should be in the radian mode. Let me go over here. This question took hardly how many minutes? 4 minutes. And this question is taking like another 4 minutes. Sine, cos, tan, calculator in radian mode. These are the formulas. Now let's read the question. The question says the diagram shows a sector ABC of a circle. Hold for a second. The sector is that of a circle naturally with center A and radius 8. Center A and radius 8. Usually center is maybe some other point. And over here, I'm just switching it around. Okay. So now it's saying that this is the center. This is 8. This is 8. What else is there? The area of the sector is this much. The point D lies on arc BC. Point D lies on arc BC. And the area of the sector is this much. Find the perimeter of the segment that is this thing, BCD. Now, the very first thing that needs to be done is that plug in the area, plug in radius, half is there, find theta. So theta comes out to be pi/6. That's a nice number. So it is 30 degrees, but we won't work in degrees. We will be working in radians. So this is the first thing that you achieve. Now we are interested in the perimeter. So I need the arc length. I need the chord. For the chord, I'll use cosine rule. So 8 square minus 2 into 8 into 8 into cosine of pi/6. I'm working in exact ratio. They did not specify exact or inexact. They did not specify. I'm working in exact. So BC is this thing. BDC is arc length. S is equals to R theta. That's 8 into pi by 6. Right now, it's in the exact form. Now, I can leave the answer as it is. I can go one step further and leave the answer in the exact in a decimal form, but make sure it has been rounded off. So it's a pretty basic question, and 4 minutes is a good time to finish it off. So question number 4 is done. Question number 5. Now, question number 4 had no parts, only one part. Question number 5 again has no parts. Now read the question for yourself and then I'll get started. Question number 5, it says, the lines with equation y is equals to kx minus k, where k is a positive constant, is tangent to the curve with equation y is equals to minus 1 over 2x. Find in either order the value of k and the coordinates of the point where the tangent meets the curve. I do this question by quadratics because it's a normal quadratic kind of thing. Some people, they also prefer to do it by differentiation. I personally prefer quadratic. Make a single equation in terms of x and then apply the discriminant concept. Its tangent b square minus 4ac equals to 0. So I'll first find the value of k. Once I find the value of k, I'll solve these two equations simultaneously. I'll find the coordinates of the point. That means the x and the y coordinates. All good, all clear for 5 marks. So 5 to 6 minutes is enough. So now 7:34 to 7:41, maybe I did a lot of explanation. So that is why it took 7 minutes. So now this is quadratics, b square minus 4ac equals to 0, line curve, single equation, simplify, write in the proper order, first x square, then x, then constant. Separate out what is a, what is b, what is c, b square minus 4ac equals to 0. Again, take common. K is equals to 0, reject because 0 is neither positive nor negative. K comes out to be positive too. Now, when we use the quadratic formula, and if the discriminant is 0, the whole x value boils down to this. You just get one answer. So what I did is that in this particular single equation, I plugged in the value of x is equals to k equals to 2. I get this equation. I plug in minus b over 2a, I get half. If I don't want to do this, if I don't have the knowledge, which definitely I should, I can just go ahead and factorize and I get x is equals to half. Plug x coordinate in either the line equation or the curve equation, whichever one you feel is simpler, you find the y coordinate. Therefore, the coordinate is half and negative 5. So I think this is also pretty basic. That is this thing. Let me do one more question, which I cannot do because we have not studied AP-JP for the mock exam. This will be coming up later. So this is AP, a very nice chapter. And let me do this question, then I'll go to the examiner report. Now it says a curve has this equation y is equals to 2 plus 3 sine half x for x lying between 0 and 4 pi. So we know that 2 pi is 360 degrees. 4 pi is 720 degrees. This is 2 plus 3 sine half x. First of all, we know that the maximum value of sine is 1. The minimum value is negative 1. They are asking for greatest and least. So 3 into 1 is 3. 3 plus 2 is 5. That's the maximum. 3 into minus 1 is negative 3. Negative 3 plus 2 is negative 1. That's the minimum. Or some people can sketch the curve and then based upon the curve, they can write this thing. It's their choice. Now, when we talk about cosine, when we talk about sine, cosine kx, sine kx, k cycles in 360. Therefore, this is half. The value of coefficient is half cycle in 2 pi. But we are drawing till 4 pi. So therefore, we will draw one cycle. Is this thing clear? I hope so. It's all good, all clear. If not, someone can ask the question separately on the WhatsApp. Okay, so now this concept of number of cycles. And let me write over here trigonometry. So that is the thing that I was focusing on, number of cycles and trigonometry. Okay, so now this thing over here, +2. So I have drawn a dotted line like this, just to show that this is 3 units up, 3 units down. That's the amplitude. And it's one cycle from 0 to 4 pi. And I think the grid was already drawn over here. Yeah, the grid was already drawn. And then sketch the curve for 2 marks, greatest least for 2 marks, fair enough. State the number of solution of this equation. So now this is related with O-level maths graphical solution of equation 2 plus 3 sine half x. This is what you have drawn. Replace this with y, 5 minus 2x. Draw the line 5 minus 2x. Find the x-intercept, find the y-intercept, just join. One other point, if you want to, you can. Some people, they prefer to draw up a table. Any which way, draw the line. So now this is value is 2.5. So we know that pi is 3.142. So 2.5 would be a little bit lesser. So this line is not exact, but it is realistic. How many points of intersection? 1. Therefore, one solution. That is the answer for this particular question. So now let me pause over here and let me go to the exam report. So this is up till question 7. 6 is skipped. So that's the exam report. Now let me start reading the general comments. So now the general comments, what is it about? It's about the performance of students. So now it says some very good scripts were seen, although generally the paper was found to be quite challenging. Well, up till now, I did not find it challenging. Neither should you. Yes, maybe one question or 2 questions at the end would be challenging. Success in this paper requires candidates to be familiar with mathematical methods specified in the syllabus. Of course, that is what we learned the whole year. And to understand when to apply them. Yes, this is necessary, when to apply them. While some questions involved interpretation and problem solving, the bigger questions, several of these questions were easily accessible to candidates who had practiced these methods. Candidates should be reminded. So let me change it to highlighted. Candidates should be reminded that they take care of their presentation. Now, this is something that I'm speaking about the whole year, and we'll speak about it right after mock when we'll be completing the rest of the syllabus and past papers. So presentation is everything. When candidates make several attempts at a question, they should clearly indicate which solution is to be marked by crossing out unwanted working. Do not overwrite, that's one thing. And if you are doing this trial and error because of lack of practice, which is not a good thing, so just tell examiner exactly this needs to be marked. If there is insufficient space, they should use the extra page at the end instead of writing in small spaces within another solution. I think the examiner is too angry with some of the people messing up the whole paper. They were not taught properly, as you are lucky enough to be taught properly. Clear working will minimize the risk of making errors, though misreading their own work. Like a student is reading his or her own work, and that person is confused. I mean, where is this value coming from? So how do you expect the examiner to have a clear head and give you the marks? Some of the answers were written in pencil, already talked about it, which is then superimposed with ink, giving a very unclear image when the script is scanned. In other words, the examiner is telling you, if it's not scanned properly, you won't be getting the marks. So don't cry about it later on. Centers are strongly advised that candidates should be told not to do this, okay? I have told you many, many times, don't do it. Be confident, have a good practice. That is what mocks are for. Now let's go to each particular question. Now, question number 1. It says most candidates started by rewriting tangent as sine over cos, but many could make little or no further progress. Those who found the solution did so without factorizing, so could not be awarded the second M1 mark, method mark, only the SC mark for correct answer. Some candidates multiplied through by sine theta to generate sine square theta in order to use the relevant identity. Weaker candidates use incorrect trick identities. Sine square theta is 1 minus cos squared. There is no such identity as this. A small number solved cos theta is 1/4, leading to 75.5, gave the answer as 104, which was not rounded to 1 decimal place, so could not be awarded the final mark. That means the examiner focused on accuracy, the examiner focused on factorization, the examiner focused on the methodology, that the steps that needs to be very, very clear. I have told you every single step. So basically, this examiner report is confirming, it's highlighting, it's emphasizing the fact that whatever I have told you, just follow that. Question number 2. Candidates who were familiar with the binomial generally produce accurate methods in A and B, though sign errors were seen in second and third term in B. That means these people, they were not sure that a negative number raised to an odd power is giving us odd, negative raised to an even power is giving us even. So make sure it's giving us positive. So let me write over here, this is positive. So odd is giving us negative, even is giving us positive. That is what you need to focus on. Those who attempted to multiply brackets instead were prone to error, some confusion over which terms were needed with the constant term omitted in some cases. Some candidates were awarded both marks, having found the expansions correctly, then identifying the term that contributed to the coefficient in x squared. Those who had incorrect expansions but successfully multiplied. I mean, these are all the different things. In short, just follow whatever the working that I've shown you. As simple as this. Question number 3. This is one of the new topics, that is transformation of function. There is evidence that candidates are better prepared for this kind of question, with some using correct terminology. So inshallah, you people, when you'll be giving the exam, they will be writing about you that you are the ones who will be using the correct terminology in a fully correct solution. Yes, you will be the star people. A translation should be described using a vector or a clear statement that it was translated left horizontally or in the negative x direction by 6. I'll write the statement, I'll give the translation vector. When we talk about stretch, it was necessary for stretch. It was necessary to specify the direction in case the y direction or vertically and the scale factor 2. So now all these things were necessary. Let me just highlight this. So specify the direction and the scale factor. A number of candidates misinterpreted the question, provided instructions for reverse transformation. Why did this thing happen? Because they did not read the question carefully. That is about this thing, which is this thing. Clear working must be shown, and I think read questions carefully. That's where it's written. Often there was more description present than needed, which led to multiple answers, some of which were contradictory. That means whenever it's an old saying that speak whatever you asked to and speak in limited words and don't blabber. So that means whatever you write, that should make sense. Otherwise, one part will be contradicting the other. Hence, you'll be losing the marks. Question number 4. Most candidates found the correct value of theta in radians and the arc length. Stronger responses use correct trigonometry. Splitting triangle into 2 right angle triangles. I don't know what's the need for that. Or using sine 1/2 pi to find half the length. I don't know what people are these. Why don't they just go ahead and use cosine rule? An alternative method was to use cosine rule to find the length of BC. Candidates should learn these rules and use them correctly. In order to award the method mark. Some candidates attempted to find the area of the segment rather than its perimeter. Again, not reading carefully. Other assume that ABC was right angle triangle and wrote BC as 8 tan theta. Now, this is the limit. Why would they assume this? I don't know. Question 5. Now it says candidates appeared to find this question challenging. Many of them were unable to proceed with the method of introducing multiple algebraic or sign errors. This is the quadratic one. Successful candidates generally equated y for the line and the curve to reach this quadratic equation. Use b square minus 4ac to find k. It was common to see this becoming this. So this is an error leading to incorrect equations. Despite a number of candidates attempted to use the discriminant, some candidates did not reject k is equals to 0. Very important. Some candidates did not reject k is equals to 0. It said clearly k is positive. When candidates solve a quadratic equation to find two possible answers, they should check both answers make sense in the context of the question, correct? In the alternative method, some did it by differentiation. I don't want to read this. Question number 6, that's AP, ignore it. Question number 7, that is trigonometry. Let me highlight this. Those who considered the maximum and minimum values of sine theta could deduce the maximum and minimum value of the overall expression. A large number of candidates, just checking, a large number of candidates stated 2 as the least and 2.33 as the greatest, simplifying by substituting lower and upper values. I don't know who are these people. I don't even want to talk about them. For some, there was some confusion between range and domain. Again, I just want to keep quiet. Other candidates seem to not understand the question. The values in part A were incorrect, but in graph, they showed the correct maximum and minimum. That means some people can draw the graph and then give answer for this particular part like this. So they can also do this. Many candidates sketched the sinusoidal curve, but the period was often incorrect. Others supplied a non-periodic graph. Sketching graph is a necessary skill and should be practiced without first drawing up a table or table of values. Sketching is without table of values. Candidates who used the incorrect maximum minimum were awarded follow-through marks. The majority of candidates either attempted to solve an equation or made a guess at the number of solutions. More successful candidates, yes, they're talking about you people, use the sketch to consider intersections on the graph, concluding there would be only one solution. So now we have read up till this one. Now let me just write something on the WhatsApp group. And let me first write it. So now exam report, helpful or not? So helpful, a tick mark. And I don't think so anyone would dare writing not. So let me just write exam report, helpful. And this is 1, this is 2, okay. Now, people, let me go back. That is how you thoroughly understand a paper. And that is the way that I have explained the paper on the past paper solutions that I've given you access to. So now over here, the functions f and g are defined as follows, where a and b are constants. So fx is this thing, this weird expression, x is greater than a. Gx is a straight line. X is an element of real number. X is an element of real number. It means all real values of x. So now they are saying f of 7 is 5 over 2. Plug in 7 over here, equal it to 5 over 2. Plug in g of f of 5. G of x is given. G of f of 5, plug in and equate it to 4. F of 7, this is what you are getting. Simplify, you find the value of a, which is 3. G of f of 5. So instead of finding g of fx, my bad. So instead of finding g of fx, what I did, let me first find f of 5. That is 1 plus 2a over 5 minus a. And I did not substitute it over here. I worked it symbolically. I could have, but maybe I forgot. And then g of f of 5, that means this whole thing will be substituted in gx. Bx minus 2, they will be substituted in x. And at this point, I substituted the value of A is equals to 3. So I found the value of B, which is 3 over 2. So A is 3 and B is 2. Therefore, fx is this reciprocal function, which is 6 over 3 minus, which is 6 over x minus 3 for x greater than 3. That is the fx, and it will be used on the next page. It says for the rest of the question, you should use the value of A, which you found in part A. For the domain, find the domain of f inverse. Domain of f inverse is range of fx. Fx is 1 plus 6 over x minus 3. This you have done in class. This is a over x minus h plus k. That is how you draw it. You can also draw it by saying that this is a transformation of 1 over x. So 1 over x is becoming 6 over x. That is steepness. That is stretching. That won't change a bit. And then 1 over x is changing to 1 over x minus 3. It's a horizontal shift of 3 units to the right. So we draw the asymptote x is equals to 3 because the original asymptote is over here. And then this plus 1, that is a vertical shift. So the asymptote y is equals to 0 becomes y is equals to 1. And then this graph is drawn with the perspective of this. The domain is x is greater than 3. This is x is equals to 3. It's not inclusive. So we are just focusing on this thing. The lowest y value is 1. All the other y value is going towards infinity. So the range over here is fx is greater than 1. Therefore, the range of fx is greater than 1. Therefore, the domain of f inverse is x is greater than 1. Why is it minus 1? I think it's 1. Okay, all good. Find an expression for f inverse. That is something very basic. Let y is equals to fx, f inverse y is equals to x. Y is 1 plus 6 over x minus 3. Y minus 1, make y the subject, make x the subject. X is f inverse y, and f inverse x is 3 plus 6 over x minus 1. So this thing is done. Let's read the exam report for this. Many candidates wrote this thing followed by poor algebra. I'll just highlight the basic stuff. It's about poor algebra. It's about common error was omitting to multiply by 1 when multiplying through by 7 minus a to clear the denominator. Again, basic math. That is where people are lacking. And next one, a small number of candidates found the correct answer of x is greater than 1. So over here, I think by mistake, I have written -1. So let me just erase this. Okay, let me focus over here. The range of fx is the same thing as domain of f inverse. Domain is written in terms of x. So I have just corrected this. A small number of candidates found the correct answer. Many confused the range and domain. Other gave answers such and such. A large number gave such. Poor notation was often seen. Successful responses swapped the variable and made y the subject. The way that I have taught you, just follow that, reaching a correct expression for f inverse x and in a few lines of working. Many algebraic errors were seen. Unclear work was a hindrance. Unclear work was a hindrance for some candidates. Before the examiner, they themselves are hindered. Let's move to the next question. Now I'm just using this particular PDF to read it out. Now the question says, water is poured into a tank at a constant rate of 500 centimeter cube per second. The depth of water in the tank t seconds after filling starts as h. When the depth of water in the tank is h, the volume V of water is given by the formula such and such. Find the rate at which h is increasing at this instant. So now I just need to take a small break. Let me just pause the recording. Hold for a second. So now over here, this equation is given, this weird equation. Find the rate at which h is increasing at the instant when h is 10. Volume in terms of h, differentiate. The constant disappears. Power comes down. Bracket remains as it is. Power reduces by 1 into derivative of bracket. dv by dh is this. Plug in h is equals to 10. dv by dh is 4 into 35 square. Find the rate at which h is increasing. Volume in terms of h in terms of t, volume in terms of t. dv by dt, that's given. dv by dh, that is found, into dh by dt, and this is your answer. Leave the answer in the fraction form. At another instant, the rate at which h is increasing is this much. So now they have given us dh by dt. Find the value of v at this instant. So now dv by dt is the same. What am I doing? I have dv by dt, I have dh by dt. Let me find dv by dh, equate it to the expression of dv by dh. I'll find the value of h. I'll plug the value of h in the volume equation. I found the value of volume. Have a good look. Nothing difficult, but it was a multi-step problem. 2 steps were there. First, find dv by dh. Actually, 3 steps. So step 1, let me highlight. Use a white marker. So this is step 1. Up till here is step 1. This is step 1. This is step 2, finding h. And this is step 3, that is finding v. So there were 3 steps involved, which you have to think for yourself. I'll go to the examiner report after question 10. Now this question, let me show you the original one, because this is already too messed up because of all the necessary working that you need to do. Okay. Now this is the original question. And this time now I'll read the examiner report at the very, very end. The diagram shows part of the curve with equation such and such, and parts of the line y is equals to 1 and x is equals to 1. So this is x is equals to 1. They did not draw the full line, y is equals to 1. The curve passes through the point A and B. That's A, that is B. Find the exact volume generated when the shaded region is rotated 360 degrees about the x-axis. That is first part for 5 marks. A triangle is formed when the tangent to the curve at B, the normal to the curve at B, and the x-axis. Find the area of this triangle. So this is B. You will draw a tangent like this. You will draw a normal like this, perpendicular, and the x-axis. So basically, you need these 2 x coordinates. You have this coordinate, and you will find the area of this triangle. So that is the basic logic that we will apply. Now, first of all, we need, it's rotated about x-axis. The limits are already there. So now over here, what we do is that this is 3/2. This is 1, limit is there. You would integrate this curve and you will subtract this region. So volume produced by the curve, that is this equation squared, 4 squared becoming 16 comes on the outside. 2x minus 1 power 2 raised to power of 2, power 4 in the denominator, negative 4 in the numerator, because for integration, you need to take it up. Then you apply chain rule of integration, increase the power by 1, divide by the new power, divide by the coefficient of x. And over here, then you simplify. You have a negative over here. Get rid of this negative, change the position of the limits. So 1 goes up, 3/2 goes down. Plug in the limit, show the working. This is your answer. That's volume produced by the curve. But the shaded region was not all the way till the x-axis. There is this line, y is equals to 1. Square it, integrate it, becomes x. Plug the limit 1 and 3/2. That comes out to be half pi. So the volume that is required is the difference between the two. I think it's pretty basic, provided you don't forget the steps. First square, then integrate. Actually, first square, simplify, 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 then integrate, then plug in the limits. Don't forget to multiply by pi. Now let's look at this particular question. It says a triangle is formed. So now we are looking for the tangent. This is the equation of the curve, differentiate. Plug in the x coordinate of B. you get gradient of tangent. Dy by dx is -2. That's gradient of tangent. Gradient of normal is negative reciprocal. That's positive half. So let me write over here that is gradient of normal is negative reciprocal of gradient of tangent. And then this is the coordinate that you have. So let me just highlight this. So this is the coordinate that you have. That's plugged in over here. That's plugged in over here. You find two tangent equations. Do not open up the bracket. In both of them, make y is equals to 0 because for x-intercept, y is 0. For this. So this is y is equals to 0. Let me highlight. So this is y is equals to 0 over here. This is y is equals to 0. That is over here. And then we find this thing. And then we find two coordinates, 2, 0, and this, 0. Okay. So if I'm not mistaken, it seems like I think I made an error. Y, acha, this is y is equals to 0 over here. So I plugged in over here. So let me 0. So I was just wondering, where did that 0 go? So this is like 0 minus. All good. So this is 0 minus 1. And then you simplify. So you get two answers. One answer is this one. That is 2, 0. The other answer is this one, that is minus half, 0. And you just draw a rough diagram. This is negative half. This is positive 2. The base is how much? 5 over 2. The height is how much? The y coordinate. Half into base into height, you get 5 over 4 square units. So now this is a question on volume, differentiation, rates. These are the questions that I have done so far. So let me write over there. So this is rates of change, also known as related rates of change. Then volume of revolution. And then it's a tangent, normal, area. So I hope this is all good, all clear. I'll read the mark scheme at the end. Okay. So now this is done. Let me move to this question. That is 11. And there are 12 questions, so 2 more to go. So now it says the equation of a curve is this. Dy by dx is given. A is a positive constant. Curve has a stationary value. Find the value of A. So first of all, dy by dx is equals to 0. Plug in x coordinate as A, and you will find the value of A. Then integrate, plug in x as A, y is negative 15, and you will find equation of curve. So basically, I told you the working for part C. Nature, double differentiate d square y over dx square, also known as y prime in terms of function f double prime x. Plug in the value of A. If it's negative, it's maxima. Positive, it's minima. Find the coordinates of any other stationary point. You take this dy by dx equals to 0. One of the point will be this. They're asking for the other point. So that is question number 11. Let's look at the working. I think it's pretty basic. Stationary point, dy by dx is 0. X coordinate is A. Dy by dx is 0. You are getting A is equals to 4. Determine the nature, double derivative, plug x is equals to 4, and you are getting it positive. So therefore, it's a minimum. Part C, integrate each term individually. There is a constant of integration. Plug in x is 4, y is negative 15. This is A and negative 15. That is what we are plugging in. You find C is equals to 1. You find the equation of the curve. Coordinates of any other point on the curve, take 6 common, no issue, because it's equaling to 0. Middle term factorization, x is equals to 4 was the given point. That was the A. X is equals to 1 is the other point. Plug in, you find the y value. This is the y coordinate. Now we are moving to this last question, which is about circle, a nice question. So now this is about stationary point. That thing is done. And last is about circle equation. And then we will be going to the examiner report once again. So now, first of all, before I read anything, this P is the name of a circle. This Q is name of another circle. There is a point on the big circle. This is the tangent. This tangent is cutting the other one. This is the y-intercept. Maybe they would be asking something about this. The diagram shows a circle P with center 0 to radius 10. In other words, we can write down equation of a circle. X minus 0 whole square, y minus 2 whole square is equals to 10 square. That's too basic. The other circle has a point, no, other circle, no. This circle has a point A with coordinates 16. Now, this is the point which is 16. It also shows a second circle Q with center at the point where tangent meets y-axis and with radius 5/2 root 5. And now it says, find the equation of the tangent to the circle P at A. That means from here, what is the center? The center is 0, 2. This is 0, 2. This is 16. Find the gradient. Tangent should be negative reciprocal. You have the point, you find the equation of tangent. That is also basic. I'll just show you the working once. Find the equation of circle Q. How can you find equation of circle Q? It also shows a circle Q with center at the point where the tangent meets y-axis. So when the tangent meets y-axis, x coordinate is 0. When x coordinate is 0, you find the coordinates of Q. You already have the radius. That's also basic. Verify that the y coordinates of both of these points are 11. Verify the y coordinates of both of these points of the intersection of the two circles are 11. So this I have to show you the working. Find the coordinates of the point of the intersection of tangent and circle Q. This is simultaneous equation giving answer in third form. 3 mark, 3 mark, 2 mark, 1 mark, altogether 9 marks. Okay, so let's get started. That was very basic. Gradient of CA. This is C, center C. This is A. That comes out to be 4/3. Gradient of tangent negative 3/4. It's passing through 6, 10. That's the equation. This is I'm using for part C. What is that? Y-intercept, x is 0. So y is 29/2. That means for circle Q, let me write over here. For circle Q, the center would be 0, 29/2. That is used up later. Now, center of circle Q, that's right over here. I've written it on this side. That's good. And now it says find the equation of circle Q. So that is the center, that is the radius, that is the equation. So this is, let me write it again, x square y minus 29/2 whole square is 125/4. This is the simplified format. This is equation of circle Q. Now they are saying that y is equals to 11 is the intersection of two circles. That means if I plug in y is equals to 11 in this equation, I should get the same x coordinates. So I plugged in y is equals to 11. I get x is equals to plus minus root 19. X is plus minus root 19. Let's double check. These are the 2 points of intersection. This is x is equals to plus root 19. This is x is equals to negative root 19. This thing is also done. And then it says, find the coordinates of the point of intersection of tangent and circle Q. That's the equation of tangent. That's the equation of circle Q. So now what we do is that, first of all, focus on this one. So let me just use a thick white marker over here. So over here, I'm focusing on this thing. That is, let me just erase this thing. Okay, so this is the simplified form of the tangent equation. Y is equals to negative 3/4 x plus 14.5. This is tangent equation simplified in the form y is equals to mx plus. Now keep in mind 14.5 is the same thing as 29/2. So now when I plug it in, you see a 29/2 over here in this equation. You see a 29/2 over here in this equation. So luckily, things get cancelled out. And we are having this equation x squared negative 3/4 x, the whole thing squared. This is cancelled out. That is 9/16 square is 125/4, multiply throughout by 16 or take LCM or whatever. So x comes out to be plus minus root 20, which is written in the third form. So simplified. 20 is 5 into 4, root 5, root 4. That is root 4 is 2 root 5. That is the answer. That is the coordinates of the points of the intersection of this thing in the third form. So now they are intersecting at two things. So now this is circle intersecting with this Q, the tangent intersecting with this Q. Equation of points of intersection of tangent and circle Q, give your answer in this form. And I think I've just did a little bit of working over here. And you also need the y coordinates. So you plug it in over here, and the y coordinates are also coming out to be in third form. So now this was a little bit tough question. So now let's go to the exam report. And I hope up till here, it's all good, all clear. So I think one paper saps away all your energy. And I think we just have enough energy left to go through the exam report. Now, question number 9. The majority of candidates did not appreciate that the question about rates of change required differentiation. Again, who are these people? How can they even think about this? Did not appreciate that the rates of change required differentiation, so could be awarded no marks. Some did not attempt the question at all. Of those who did, a common error was to substitute H into the volume formula. Only the strongest successfully used dH by dt to form an equation in H using the chain rule, that dV by dt, dV by dH, dH by dt, that's the chain rule. After solving to find H, the value was substituted to find the volume formula and the volume given to at least 3 significant figures. Many candidates did not answer this question, but those who did often did not realize differentiation was needed. The most common error was to substitute this thing. Question number 10. In this question, candidates need to show all steps in integrating. I'll just focus on this. Using the calculator for integration was not sufficient. Volume of cylinder subtracted correctly and final answer given in exact form with pi included. Errors were seen in integration. Power reduced rather than increased, or the chain rule omitted. Some candidates appeared to be unsure whether to differentiate or integrate. A minority of candidates produced fully correct solution, clear strategy, logical working, and a diagram. Diagram is must. Those who found the normal gradient, the tangent, and the normal question often went to find the equations of normal and tangent, the intercept with x-axis. Some found the problem-solving aspect of this part more challenging. Others often threw an incorrect or no diagram. It is often advisable to sketch a new diagram rather than working with unclear annotations. Many candidates omit to use the chain rule when differentiating, and power errors were common. Some candidates use the given information to substitute x is equals to a into dy by dx, set it equal to 0. From this, they obtain a is equals to 4, quadratic formula. Most candidates use second derivative. Some candidates had no a value to substitute, while others made arithmetical error that led to wrong conclusion. Many candidates integrated correctly, proceeded to find this thing. In this type of question, candidates should take care to write an equation correctly. The final answer, write it correctly. In this question, it was necessary to demonstrate a method of solving the quadratic equation. It was then straightforward to substitute x is equals to 1 in the expression to obtain 1, 12. A large number of arithmetic errors were seen. Most candidates found the correct equation of a circle, but 10 or root 10 were common. Other errors including omitting the square bracket, swapping x and y, and sign errors. Some pleasing geometry work was seen. Many candidates successfully found the radius, then used the correct equation of the radius. Other inverted the gradient or omitted to find the perpendicular gradient. Candidates who attempted to find the gradient or the tangent were generally less successful. You don't have to differentiate. No. This is a coordinate geometry question. Many candidates used the answer to part B to find the equation of circle cube. Others did not link the two parts of the question, so were unable to form an equation. How can you not link? Most candidates did not attempt to verify the y coordinate of the point of intersection. Those who did often equated x square or y square from the two circle equation to obtain y is equals to 11. A quicker method was to substitute y is equals to 11. That is what we did. That is what you will do. Both circle equations to show that the intersection of occurred at the same x or x square value in both cases. Stronger candidates substituted the equation of the tangent into the circle and then solved to obtain x is plus minus root 20. Some were able to find the correct exact values of y also, some, not all. A number of candidates seem not to understand the meaning of the third form, which is mentioned as required prior knowledge to the syllabus. So that's all about it. And that is all from my side from Mathematics with Shahab Yaqub, a comprehensive solution of this particular paper. Take care, everyone.